AP Environmental Science 4.9, El Niño and La Niña. We have the classic SNL genius Chris Farley on his skit where he was El Niño. It's Spanish for the Niño. All right, quick review. We have gyres. They're the 5 large-scale ocean currents. There are many smaller ones, but these are the 5 big ones. They move clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. They move from east to west, regardless of hemisphere. East to west. You have those warm equatorial waters moving north or south towards the poles, and you have that cold polar water moving north or south towards the equator. Depends on your hemisphere. We have this concept of upwelling. Upwelling is when cold, deep ocean water that has a lot of nutrients in it gets pulled upwards. It's pulled upwards to replace the warm surface water that's being blown away from the shores of continents. As that water is pulled up, because it's so full of nutrients, it can support large phytoplankton populations, the producers of the ocean. Those phytoplankton are consumed by zooplankton and fish, which are consumed by larger fish, which are consumed by larger fish or sharks or whatever. The phytoplankton are the base of the marine ecosystems. They're the producers. So more phytoplankton means higher productivity, means lots of plant growth. It also helps regulate temperature because you're having that cool water being pulled up from the bottom. So it keeps your water a little more temperate than normal. These are the areas where upwelling happens naturally. If you notice, it's mainly along the western coasts of continents, because remember, predominantly those ocean currents are moving from east to west, so that warm ocean water is being pulled to the west. So it's being pulled from the western continents, from the western edges of the continents to the east. Go the western coasts of continents. Winds blow away from the land. It pulls that water, pulls up that water. Yet another diagram of upwelling. It's showing those large fish populations that are possible because of the phytoplankton that's able to grow from all those nutrients that are being pulled up from the ocean floor. All the nice sediment. This one specifically is on the western coast of the U.S. off of California. And here's a temperature gradient. It's showing you that the cold water from the bottom of the ocean is being pulled up close to the shore, and that warm water is being pushed away from the shore. Again, this is off the western coast of North America. Okay, now, we're into the actual El Niño part. First, we have ENSO, which is El Niño Southern Oscillation. That's one of the terms for El Niño. But what happens during it is that trade winds that are normally blowing from east to west weaken or reverse. So you don't have wind pulling water from east to west as strongly anymore. Or during the worst ENSOs, it's blowing from west to east. It completely reverses. So normally, the warmest part and wettest air from the Pacific Ocean is centered over Indonesia and Australia. But during an ENSO, since that air isn't being pushed as strongly to the west, it shifts more east to the middle of the Pacific Ocean, closer to South America. Because the winds aren't blowing as strongly, it's not pulling that ocean water away from the coast of South America, so it's not pulling up that cold water as strongly anymore. So that upwelling doesn't happen anymore. Those nutrients stay at the bottom of the ocean. The bottom of the ocean, there's not as much light, so even though the nutrients are there, the phytoplankton aren't living there. So the food chains along the coasts where this upwelling normally happens don't have as much energy available anymore because the phytoplankton populations decrease. Here's a visual showing what's going on there. Normal conditions, you have that upwelling. It's pulling these, in this case, nutrient circles up, and there are a lot of them. But during an ENSO, in El Nino, the water is not being pulled away as strongly, so more of those nutrients stay at the bottom of the ocean because that cold water is not being pulled up to replace the warm water. Now here it's showing that shift in precipitation and temperature, not necessarily just the upwelling, but normally you have this warm, wet mass of air over Indonesia and Australia. During an El Nino, it shifts to the Pacific Ocean or all the way over to South America. That warm, wet air is responsible for a lot of the precipitation here in the tropics. When it shifts to the east, it carries that moisture with it. So you end up with more droughts over here. You don't have as much rainfall, and you have way more rainfall on the western edges of your continents, where traditionally, particularly on South America, this area is pretty dry. Now you have a lot more precipitation and temperatures are warmer. Here we go. Again, it shows that here it gets very dry because that normally wet, moist air that's concentrated over Indonesia is shifted over to the east. Now it's out in the middle of the Pacific Ocean or all the way over to South America, where now it's warmer than normal and wetter than normal. Now, El Nino does have impacts around the entire world. College Board tends to focus on here, on the western edge of South America, and here in the American Southeast. We have a repetition. The decrease in upwelling results in the decrease in available nutrients, which decreases phytoplankton populations, which decreases primary productivity. If you decrease your primary productivity, the second law of thermodynamics says that there's less energy available up the food chain, so you have a decline in your fish populations that rely on the phytoplankton. It's a whole chain of consequences. And here are the resultant weather patterns. You have dry, it's droughts. Here you have lots of rainfall. That can lead to flooding or landslides. It's very steep from the Andes Mountains on the coast of South America. So if you have increased rainfall, the soil is not going to be held in place as much, and it can slough off and be pretty destructive. And once again, here's just another graphic showing the normal versus El Nino conditions of weather. Then we had a short video, but we're not putting a video within a video because that's just way too meta. Now the converse of El Nino is La Niña. That's where the trade winds get extra strong. They're blowing extra east to west, so that warm water that's normally over Indonesia and Australia gets pushed extra to the west, and it ends up in the middle of the Indian Ocean. Whereas the coast of South America gets extra dry because that moisture is being pushed even further. You have increased upwelling, so sometimes ocean temperatures can drop more than normal. Fish don't like that, so they leave. During La Niña, there are more hurricanes in the Atlantic Ocean. Winters in North America get much colder, as those trade winds are pulling that colder Arctic water and colder Arctic air towards it. You have a lot more flooding in Southeast Asia because they're getting more rain than normal. And those extra droughts in South America can result in lower agricultural yields. El Nino and La Niña are very common concepts in multiple choice questions, so make sure you're very familiar with El Nino, La Niña, and normal climate conditions.